Welcome to our discussion on incorporating references to external knowledge bases in prompts. We'll explore how connecting language models with these sources enhances AI capabilities for more accurate, up-to-date, and reliable outputs. Enhancing AI with external knowledge improves response accuracy by incorporating verified facts. It provides up-to-date information beyond training cutoffs, creating more trustworthy systems with verifiable answers. This integration expands AI capabilities into specialized domains, addressing the limitations of large language models. Knowledge integration methods include retrieval-augmented generation, which combines search and text generation, knowledge prompting for factual guidance, and API and database references for real-time data access. These methods enhance AI's accuracy and relevance by integrating external knowledge sources. A knowledge base is a structured repository of information. It includes databases, APIs, vector stores, and document collections. Examples range from public sources like Wikipedia to private company documentation and proprietary databases. These repositories facilitate organized access and retrieval of data. Internal model knowledge is fixed at the training cutoff date and may lead to outdated or hallucinated information. In contrast, external knowledge sources provide up-to-date, verifiable data, including proprietary information, enhancing specialized expertise. AI models often lack knowledge on events post-training, specialized domains, proprietary data, rapidly changing information, and personalized contexts. By comparing model outputs with trusted sources, you can pinpoint where external knowledge is most beneficial. To evaluate an AI model's native knowledge, start by asking probing questions to establish a baseline, assess the response quality for accuracy and depth, identify where the model's knowledge ends, and create a plan to enhance it with external sources. Use external references for recent events beyond the model's training date, real-time data like current prices or weather, and compliance requirements needing verifiable sources for regulatory adherence. For real-time data, use application programming interfaces like weather services or stock market application programming interfaces. Structured records are best sourced from databases such as product catalogs. Recent events can be tracked via news application programming interfaces like Reuters. For domain expertise, refer to specialized documents like academic papers. Company information is found in internal knowledge bases, such as employee handbooks. Retrieval-augmented generation, or RAG, merges traditional search with generative AI. It searches external sources, retrieves relevant documents, and integrates this data into the context window. This approach, introduced by Facebook AI Research in 2020, enables AI systems to generate responses using both model knowledge and retrieved information. A RAG operates by processing a user's factual query into search terms or vector embeddings. It retrieves relevant documents from a knowledge base, augments the context with this information, and generates a response using both the retrieved data and the model's own knowledge. RAG approaches enhance accuracy by grounding responses in verified sources, reducing errors. They provide up-to-date information by retrieving current data, overcoming training limitations. RAG accesses specialized knowledge, filling gaps in general data. Additionally, citing sources increases transparency and trust in AI's reasoning. Knowledge prompting involves prompting a language model to generate factual statements, which are then used in the main task. Unlike retrieval-augmented generation, it relies on the model's internal knowledge, eliminating the need for external retrieval. This technique can enhance responses and integrates well with retrieval-augmented generation for hybrid approaches. Two-stage knowledge prompting involves an initial user query requiring factual knowledge. The model generates relevant facts, which are then filtered for relevance. These selected facts are injected into the prompt context, enabling the model to produce an enhanced response. Penguins are flightless birds with wing-like flippers adapted for swimming. These flippers evolved from the wings of their flying ancestors and contain the same bone structure, highlighting their evolutionary history. Thus, while penguins have wings, they are specialized for swimming rather than flying. Direct in-context references enhance model accuracy. URL citations allow specific content referencing, like using HTTPs, Judge, example.com, data.pdf for questions. Quote blocks provide authoritative insights, such as the Centers for Disease Control and Prevention's report on vaccination rates. Data snippets, like sales data from 2021 to 2023, help analyze growth trends effectively. API integration involves function calling, tool use, and plugin systems. Common integrations include weather services for forecasts, financial data for stock prices, search engines for web results, and e-commerce systems for product availability. These approaches enable seamless access to live data, enhancing functionality and user experience. Combining multiple sources enhances system capabilities. Structured databases like SQL provide precise data, while unstructured documents offer narrative content. API services deliver real-time data, and user context adds personalization. Effective systems rank and prioritize these sources by relevance, reliability, and recency for optimal knowledge integration. Integrating external knowledge presents challenges like latency issues, which can delay user experiences if not optimized. Information conflicts arise when model knowledge contradicts retrieved data, requiring resolution through confidence scoring. Additionally, context window limits necessitate summarizing or prioritizing large data volumes to fit within model constraints. Begin by assessing your application's information needs and identifying knowledge gaps. Select reliable and compatible knowledge sources. Design an integration architecture using retrieval-augmented generation or application programming interfaces. Develop prompt templates to incorporate external knowledge effectively. Finally, test and refine the system to enhance accuracy and performance. In prompt engineering, ensure structure and clarity by being explicit about needed knowledge and using consistent templates. Manage context by prioritizing relevant information, summarizing large documents, and including source metadata for transparency. This approach enhances the effectiveness and reliability of AI responses. In confidence evaluation, prioritize high-confidence facts with multiple reliable sources. Medium confidence information, with some evidence but potential inconsistencies, should include caveats. Exclude or mark low-confidence facts with limited sources as uncertain. In this case study, a financial advisory chatbot faced challenges in delivering current market data and personalized recommendations. By implementing RAG for real-time data retrieval and connecting to a proprietary client database, accuracy improved to 96%, and client satisfaction rose by 45%. The system now adeptly handles specialized market trend queries. Currently, manual integration demands explicit engineering to connect knowledge sources. Emerging models focus on self-retrieval, autonomously identifying gaps and seeking information. The future envisions knowledge ecosystems, where integrated networks of specialized models and sources collaborate seamlessly. Integrating external knowledge enhances AI accuracy and relevance. Various methods, from simple references to complex retrieval-augmented generation systems, are available. Success hinges on selecting the right sources and prompt engineering. The future of AI relies on seamless integration. Next, identify gaps, experiment with techniques, and measure improvements.